Hello, once again, this is Marsha Piolo. In today's videos, we will be talking about some structural failures in some structural buildings. As we know in engineering, there's been a lot of structural collapse, a lot of like building failures due to like too much stress applied to the building due to um, inappropriate use of materials. So there's been like different kind of elements and different kind of reasons why many structures collapse during a construction or during or during when the building is being used by individuals, by for example if a bridge is being used or a building. So in this case, we're going to talk specifically about this alley bonfire collapse, which occurred in 1999. So let's begin this presentation and learning more about this collapse. Okay, so the Aggie bonfire occurred on November 18, 1999 at around 2:49 a.m. and in which it collapsed during its construction. So this basically was a annual bonfire tradition that was being done at Texas A&T University, in which 12 people were killed and there were 27 people that were injured. So the Aggie bonfire was basically a traditional event in which a bonfire was built on the campus by students, a symbol to show the desire to win against the University of Texas located in Austin, I think. Yeah, it was. So this was basically I'm just talking about this kind of event that was being held and how basically it occurred, not occurred, but like how it basically led to the collapse of this structural and which led to people being killed and leaving people also injured. So let's continue on. Let's talk about the collapse of this Aggie bonfire. So it was a 59-foot height stack that were weighted about 500. That had like around 5,000 logs that were basically collapsed during the constructions, in which 58 people and students were there working during that time. Um, in addition to the collapse, the rescue operation took more than 24 hours due to the risk of using heavy equipment to remove the logs, because using heavy equipment such as machines would have led to the logs falling more and basically injuring those people that were still stuck in the logs and that were still basically alive. So they tried to prevent this. So basically, the team of AMM engineering department were called in to examine the site and help the workers determine the order in which the logs were basically removed to prevent any other collapse, because this structure was basically was a height of 59 feet. And due to this, the logs were being removed by hand by basically the students on the campus, by firefighters, by all the rescue um all the rescue people that came into the location. In addition to this, the logs that were being used for this structure were very large, they were very tall, and they were also heavy. So which also leads into like bad consequence, because if a log fell on top of someone, it could have literally like just hit them in the head and they could have died due to the amount of weight that these logs had. So moving on, so I'm gonna show you some pictures of what the bonfire log were and what these basically consist of. So as you can see at the beginning, we had a bonfire that in 1949, it was a small structure that was basically used with like pile up in small logs. So the dangers in this structure wasn't very strong due to its equipment that was being used. And as you could see, it was not built as high as the one that was basically built in that's been building in 1999 and like the other years, because like this started as being very low in height and required like less loads, but as time went on, um basically this alley bonfire tradition led to the increase of logs and led to the also the increase of the height. So this will be basically a traditional log that was basically used in the 1999 collapse, in which you have a very tall structure compared to the one in 1949. You could also see how people were basically working on top of it. And you could see how they were not using safety gear, I guess. They were not wearing, especially at working at that height. Safety gear is very mandatory to prevent any workers from a fall and then getting into an injury or being exposed to being like killed by the fall. Let's some investigations have been done to this event, and there's been some factors that led to the collapse. So let's start with the first element. So excessive internal stress on the logs led to the collapse. Also, the inadequate containment stress in the wires that were used to tie the logs together. The wiring broke after logs from upper tires where where basically it led to the collapse of the building logs that were used in the upper structure. And also another factor was the lack of support cables on the first stack and the use of weak wires, and in which in this situation strong wires and cable were needed to support the weight of the log, and especially when the logs were being used in a construction that was higher than 30 feet. You would definitely need stronger wires and cables to support their weight and basically be having and basically to have a structure that's strong. Let's move on to the design of the bonfire. I said previously, the bonfire has been changing throughout its years, in which it started as very small back then, and now it was basically it was um it was like the design of a wedding cake that consisted of 6 tires. As you will see, basically you see 1, 2, 3, 4, 5, 6 basically levels of these logs that were being built in this campus. It was tall and it was in the shape of a wedding cake basically. And let's move on. Let's talk about more causes of the collapse. So there's been different researchers and different investigations done to this a specific event, and there's been come up to conclusions that the collapse was basically due to the structural failure due to the loss of contained stress around the first stack. The content stress is known as a hoop strength, in which the excessive amount of hoop stress overcame the bonfire's hoop strength, resulting on the building failure. So the stress hoop basically results from upward pressure in a cylinder structure that is due to internal forces. And when relating the hoop stress to the structure, the hoop stress failure occurred on the first trial logs, which led for other failures for the other logs that were basically that were being stacked above the first logs. So since the hoop strength fell at the first log, especially at the basically the ground level, it led to the whole structure collapsing, because if the structure is not set it correctly and it's not being supported and tied together at the first stack, then yeah, there will definitely be collapse throughout the structure, because the main support, which is the ground, was not being tied correctly, was not used and with the right materials. So that's basically saying how the hoop stress failure occurred on the first log, which then led for the following logs that were located above to also fail and to shift, and it basically caused the rope to fail also. So the factors that led to the decrease of the hoop strength was the inaccurate wire strength applied and the absence of the first stack wrapped around the cable. So as I already explained, so yes, so basically the hoop stress on these in the structure decreased, which basically led the structure to fail. And what was the reason of this decrease in hoop strength? It was because there was no appropriate uh, wire being used or appropriate cables being used in the structure. Moving on, as I already mentioned, what's the primary cause to the depressed hoop strength? So as I already said, it was the inaccurate wiring strength and the absence of the lack of the stack vicinity walls. As I already mentioned before, in this type of building, in type of the structure which contained logs that were heavy and long, stronger wiring was required, and basically in which each log was required to be wired at least with other three logs. And then during some installations, they've been saying how this basically was not basically being done throughout the structure. It was not being wired around other three logs. Instead, it was just being wired to the log that was next to each other. So this basically led to the hoop strength to decrease because it wasn't basically attached together to other logs on the appropriate standards that they basically had to use, which is wired to at least three other logs. And as I already said, the absence of the cables. So basically, at the beginning, 1989, they started using steel cables to wrap around the first stack, but they were basically using cables that were not yet introduced with structure integrity in mind. So they just started using it as like, oh, let me use it, but they had no like specific not specific knowledge on the way it should be applied to the structure because every building requires a specific way of appliance. So in this situation, they were not applied correctly. And yeah, so this would be basically an image on how these bonfire work are being built on the campus. As you can see, it's as of a wedding cake shape design. And as you can see, we have workers here, and the majority of the case were students from the campus. And we also have how this bonfire construction was not a safe basically technique or safe structure to be built on because what reason for another reason is because as you can see not the right appropriate and amount of safety gears is used in case an individual fell. I feel like there also should be applied some nets around the building so in case the structure so in case someone falls they will basically be held by the net around the structure. And yeah, so there's many regulations that were not being followed in the situation, in which then led to the collapse of this Aggie bonfire in 1999 in the University of Texas. So that will basically be it in the end of my presentation. I hope that you learn about more about this event and how small detailed parts such as the cable and how the hoop stress affected this and basically led to the collapse of the structure. And like I was saying, like in this kind of field, there's many structures that fail due to minor reasons. Due to this, we work as a group in order to decrease the amount of accidents throughout the industrial civil engineering. So, in this case, many of the regulations were not being followed, and it had like the appropriate material wasn't used. There was a lot of elements that led to this structure to collapse, and basically, which led to many people dying in this situation, which was 12 players, I think. No, it was just 12 people that were basically working on this structure, and they were basically students. Um, I hope that you learn more about this event that occurred a while ago. And thank you for watching my video.